Hi students, this is the Viscosity Lab pre-lab video. Welcome to this mini interactive lab in the course. I call this a mini lab because you are not required to write a full lab report. This lab activity will just focus on how to state a testable hypothesis and how to evaluate that hypothesis. Stating a hypothesis is something we do in the intro section of a lab report, and evaluating our hypothesis is something we do in the discussion section of a lab report. I should note that not all labs require you to write a hypothesis. Analytical labs don't usually require a hypothesis, whereas inquiry labs do. In this course, you will be told if you need to write a hypothesis for a lab, and it's a good thing to know how to do for the future as well. This lab will also help us record data in tables. Recording measurements in data tables is an important lab skill that is used all the time in chemistry labs. Let's take a look at what we're going to do in this lab. We're going to be measuring the viscosity of motor oil, and we're going to compare three types of motor oil: summer oil, winter oil, and used motor oil. In order to measure the viscosity of the motor oils, we will fill a cup with oil and drop a marble into the cup. We'll measure the fall time of the marble, how long it takes for the marble to travel from the top of the liquid to the bottom of the cup. For each oil, we will perform 3 trials and average the results. We will also be looking at how temperature affects viscosity, so we will drop a marble through the motor oils at 3 temperatures: a cold temperature, a room temperature, and a warmer temperature. The purpose of this lab is really to understand viscosity as a property of liquids, to understand the effect of temperature on viscosity, and also to look at some real-life applications of viscosity of liquids. So because we're using motor oil in this lab, we'll be asking, why does a vehicle engine need motor oil? And why are there different types of motor oil? How do they work? We've talked about viscosity in this unit, but let's start off with a quick review of what viscosity is. Viscosity is a property of any substance that flows. This includes liquids and gases. It's important to note that gases behave differently, so in this lab we are only looking at liquids. Viscosity is best defined as the resistance to flow, and it's determined by the chemical nature of the liquid. Liquids have different chemical compositions, and therefore some liquids have stronger attractive forces between their molecules. We call these attractive forces intermolecular forces, meaning that they occur in between the molecules or the particles of the liquid. When intermolecular forces are strong, the liquid has a greater viscosity. Liquids that are more viscous, so the particles are held close to their neighbors, will experience more internal friction when they move, and therefore they will move more slowly. To think about viscosity, it's helpful to compare 2 different liquids. Let's take water and honey, which we all know. Water flows freely, and the reason for this is that the intermolecular forces between the water molecules are relatively weak. The water molecules don't experience much internal friction, so the molecules are able to slide past each other with relative ease. Water has a low viscosity and it flows freely. Honey, by comparison, has much stronger intermolecular forces, and the molecules are held close to their neighboring molecules. The molecules of honey experience more internal friction when they move, which causes honey to move slowly. Honey has a high resistance to flow, so it has a high viscosity. Temperature, or kinetic energy, also has an effect on viscosity. At higher temperatures, the viscosity of a liquid is decreased. As the particles gain kinetic energy, they get moving quickly, and as they get more space from their neighbors, the intermolecular forces decrease and they can move more easily. At colder temperatures, liquid particles move more slowly since they have less kinetic energy, and they're held more closely to their neighbors. Liquids at colder temperatures have a greater viscosity. Just think of the saying, slower than molasses in January. I said earlier that we'll be testing the viscosity of motor oil in this lab. Let's look at how the viscosity of motor oil applies in everyday life. Motor oil is used in vehicles to protect the engine, and it allows the vehicle to operate. The engine inside a vehicle is pretty complex, and it's made up of moving metal parts. Metal rubbing against metal produces a lot of friction, so one of the main purposes of motor oil is to lubricate the metal parts. A well-lubricated engine will operate smoothly, allowing the vehicle to run properly. Motor oil also helps reduce engine wear. By lubricating the metal and reducing friction, the metal parts of the engine are kept in good shape. But before motor oil can lubricate and protect those parts, it needs to get to the moving parts. When you first start an engine, the motor oil will be around the same temperature as the outside surroundings. As the engine runs, the temperature of the oil increases and its viscosity is lowered, allowing it to flow freely through the engine. It can take up to about 10 minutes for the engine to reach its optimal operating temperature, and most people start driving within a few minutes of starting their engine. Most engine wear occurs then during the first 10 minutes of driving, and this is often called startup engine wear. Allowing your vehicle to idle and warm up after you start the engine helps reduce startup engine wear, and it's especially important on really cold days. Starting and stopping your engine also leads to more wear and tear on your vehicle. Motor oil is also designed to absorb contaminants and carry them away from the engine parts, helping to protect the engine. After a period of time, motor oil has absorbed as much as it can, and it stops protecting as well. Instead of carrying deposits, dirt, and contaminants away from the engine, it leaves them there. An engine that has sludge on its parts is not well lubricated, and it will create friction. If you've ever changed motor oil, you'll have noticed that it's often dark in color, and it may even have a sludge-like consistency. This is because it's absorbed lots of contaminants from your engine. It's important to change your motor oil regularly. And in this lab, you will see that our sample of used motor oil is dark in color and has likely absorbed a lot of contaminants. In addition to used motor oil, we will also be testing summer grade motor oil and winter grade motor oil to see how their viscosities compare. You might already know that there are different types of motor oil. We won't go through all the types in this video, but we'll take a look at multigrade summer oil and multigrade winter oil, both of which we're testing in this lab. Winter grade oils are designed to stay in liquid form on extremely cold days when you start your engine. Winter oil is formulated to have a lower viscosity. In other words, it will appear thinner so that it can flow freely at cold temperatures. Summer grade oils are formulated differently. A summer grade oil needs to be able to lubricate at very hot temperatures. Think about sitting in traffic on a hot day when your engine is running at a very high temperature. Summer grade oil should be more viscous or thicker in appearance so that it doesn't burn up on those very hot days. So summer grade oils are designed to continue to lubricate and protect the engine at extremely hot temperatures. In this lab, our winter and summer oils are multigrade oils. Multigrade means that the oil gives you protection across a greater range of temperatures. The oil can maintain viscosity over a range of extreme temperatures, which is helpful in BC, where we experience a range of temperatures sometimes in the same season. Multigrade oils can continue to lubricate the engine at cold temperatures and at hotter temperatures as a result of chemical polymers that are ground up and added to the multigrade oil. For example, on a hot day, the polymer in the oil expands and makes the oil thicker or more viscous, which keeps it from burning up. On a colder day, those same polymer molecules will fold up and stay compact so that the motor oil is less viscous and it flows freely. So we've gone over a lot of information in this video, but this will help you as you carry on with the lab. Hopefully you have a good understanding of viscosity as a property of liquids. You understand how temperature affects viscosity, and this will allow you to make some educated guesses when you write your lab hypotheses. We've also looked at how motor oil works in a vehicle engine, and we reviewed the types of motor oil that we'll be testing in this lab. So, you're ready to carry on to the lab and to get started on your hypothesis statements. Good luck and have fun.